Hi and welcome to Optimization Lab. My name is Max. I'm Master of Science in Industrial and Systems Engineering. And in today's video, we are gonna tackle an optimization problem. Today's video is about pricing optimization. We are gonna maximize the revenue, so it's a revenue management problem as well. And the only tool today we're gonna use is Microsoft Excel. Excel is a powerful tool still in 2025. It has optimization engine, it has data analysis capabilities. I have previously talked about the data analysis in Excel. You may find the video here. I recommend you to watch that video if you're not familiar with data analysis like pivot tables or charts or something like that. But let's focus on today's project. The dataset I have gathered for you guys is for avocado sales dataset in the United States of America. Now let's briefly review our objectives. First and foremost is dataset review and cleaning. We need to find if the dataset is aligned with our task or not. Next is data analysis and curve fitting part. This is important because we do not have the demand function. By default, we need to estimate the demand function, which is a difficult thing to do. After the demand function was formed, we could continue to formulating revenue function and finally using Excel solver to optimize the prices for the demand. Pricing optimization is one of the hardest tasks to do in optimization in any business. Everybody loves to sell the products at that optimum pricing in order to maximize the possible revenue to be gained. So sharpen your attention and let's go. Okay, this is our data set, and as you can see, we have multiple columns. The product, as I mentioned before, is the avocado. There is average price, there is total volume, and there are some other features like total bags, small bags, large bags, X large bags. I don't know what that is. And the type is either conventional or organic. Then we have the region and the year. So the first thing I'm gonna do here is to change this into a pivot table in order to form our analysis data. So here we need to form our demand function. The demand function typically has prices as the X values and the quantity sold or the demand as the Y axis. Almost every demand function follows a descending behavior, meaning if we increase the prices, the quantity will be lower. In order to make the demand function data here, I'm gonna add prices as the X values and the demand or quantities being sold as the Y. Let's deploy it. So let's put the average prices in the rows and now total volume as values. You see we have sum of total volume because we need to find out how many items are being sold with that price. It could be across many regions or many cities, but the price is important and the quantity being sold. So only we have two variables. Now that we have prices and the volume, let's put this into a chart. You see, this is our demand function based on prices and the total demand. But as I mentioned before, what we are looking for here is descending chart behavior. We are likely gonna delete the values of prices below the $1, and that's because there might be some promotional activities or limited time offerings that with lower prices, the quantities sold are not as high as the other prices. As an example, when we have reduced the prices to the 68 cents, the total quantity being sold is still lower than $1. Okay, so I'm gonna copy all these values and move to another sheet. Okay, so now let's plot these values in Excel in order to find the curve that best fits to this data. So I'm gonna select price and demand, go all the way down, insert recommended chart, and the scatter plot is okay. Can we expand a bit? Now let's go to the trend line, and now you can see a linear trend line has been applied, which is not suitable for this task. I'm gonna go to the trend line options, and now you can see different methods that we could apply. For example, we have exponential, linear, logarithmic, polynomial, and so on. For this task, because of the behavior of the data shows it follows maybe an exponential behavior, I'm gonna select the exponential. Let me delete the linear. Now we have the exponential curve fitted to our data. Let me change the color a bit for better visibility. Okay. So now that we have our function being fitted to data, I can have the R-score value here. As you can see, the R-score is 0.89, which is almost okay, good for our prediction, not best. The best value is 1, and as we go far away from the 1 to the 0, the fitting accuracy becomes lower and lower. So for our task, 89% is almost okay. Now let's see what function this exponential curve has. If I press the display equation on the chart, we could have the equation here. Let me just increase this a bit for better visibility. This is our demand function based on our data. Now let's have a column here called estimated demand and see if the estimated demand is following the path of actual demand or not. Alright, so now you can see the estimated demand curve and the demand value, the actual demand value, which is colored in blue here. For the pricing optimization problem, we need an objective function. This is the basics of operation research, which is mathematical optimization that I'm going to use in Excel. We need an objective function, which here is our total revenue. Then we have our demand function times the price equals to revenue, which we are going to maximize with the best possible price that we could have. So let me just write here revenue equals demand function of price times price. Okay, so we have our decision variable as the price here. This is what we are gonna find out. The model is gonna optimize. I'm gonna add value of 1 here just for not being empty. Next we have demand for that price, which is the demand function that we have fitted our curve in it. We have the math formula. Next we have the revenue, which equals to demand times price. And finally we have price mean and price max, which I'm gonna explain what are these values in a moment. Okay, so by now we have our objective function, which is the revenue. I'm gonna make this green. This is our objective function that we need to maximize this with respect into price, the optimized price values, which is yellow here, and we have some constraints. Constraints are important to guide the optimization engine in order to reach the optimum point. This is price mean and price max. We are putting a bound on the price in order to do not exceed or go lower than this value that is the historical minimum and maximum of the price that we had. Now let's use our optimization engine. I'm gonna go to the data. Under analysis tab we have solver. Here we need to set our objective. Our objective would be the revenue. We need to maximize it. We have other options like minimum or minimizing an objective function, and the value of this is considered as equal. If we are going to set, for example, a solid value for the revenue, we could assign it here, but I'm not gonna do it now. I'm just gonna maximize the revenue by changing variable cell, which is our decision cell, decision variable price. And we have some constraints here. I would add the first constraint, the decision variable, the price needs to be lower than the maximum price. This is the constraint 1 in order to stop the price to go higher and higher. And the second constraint would be the price again be more than our minimum price in order to stop the price to go negative values or lower values that we had. I'm gonna add this again. Okay, so by now the variables are set and we just need to select a solving method. If our objective function was linear function, I could use simple XLP, which is linear programming. But because my objective function uses a exponential curve, I have to use a GRG nonlinear for this task. Now, if I press the solve button, the optimal values would be calculated. Before that, don't forget to like this video and subscribe if you have liked this video till now. You ready? Let's solve this problem. Okay, so the solver has solved the problem for us, and as you can see, the optimal price is the price that we have the most demand on it, and by that we have the top revenue of $639 million almost. So this shows some important facts here that manager might say that let's increase the price. If we increase the price, let's say from 1.04 to $2.5, the revenue because of the demand will go down, would be much lower. So now you could see that the optimization model is acting like a pricing agent here. Now let's say we have a cost of 50 cents here as the grade per 50 cents. If I add a cost of goods here as COGS, the new revenue function would be the final price minus the COGS times the quantity that we sold. The optimal price is still 1.04. This is because the demand curve is very aggressive. Product is considered super elastic, meaning that by changing the price as little as 50 cents, the demand would drop significantly down. So the optimization model decides that the best price to sell on is the maximum demand point, which is 1.04. Now, what if our demand function was not as aggressive as here? For example, a smooth linear model. So now I have a linear tail line with the formula. Let's plug the formula into the estimated demand and recalculate the values. Now let's find the optimal value if our demand function was following this trend. Now you can see that with the price tag of 1.25 or $1.25, this is the optimal point of our revenue in order to be selling on. If I go back to the 1.04, as you can see, the total revenue is dropped. So the new optimal point is 1.25. So as a conclusion here, if the demand function that you're working on is very elastic, meaning that with small changes in price, we see a huge change in demand. In that case, the optimal price point would be where the demand is maximizing. But if the demand follows a smoother shape, whether it's linear, whether it's non-linear, for example, exponential, you can find the optimal prices by solving the problem with Excel. I hope you enjoyed this video. Don't forget to subscribe and like the video. I'm new here. I really appreciate your kind support. Thank you, be optimized, and good luck.